Are you ready? Alright guys, chapter 17. TIG procedures. We're going to talk about considerations and things like that. Alright, so we're going to talk about common joint designs. Well, butt, lap, corner, T, and edge is the usual. We have a single V groove, a square groove, a double V. Okay, lap joint, T joint, edge, corner, inside corner and outside corner. Okay, pretty normal stuff. Okay, now we have a backing bar. What does a backing bar do for us? Well, it protects the root side of the weld from contamination and helps us not have excessive melt through. What happens is that we can actually stick a bar behind this, okay? And we can use aluminum for steel, or we can use copper, anything to pull the heat off so it protects it from the gas. I should say protects it from the atmosphere, and it gives us something so we don't melt through. Okay. Now, remember I was telling you about electrode stick out, how important it is? Okay, so we know 1/8 to 3/16 inch for a butt joint, 3/16 to 1/4 inch for a T-joint, and 1/8 inch for a corner. Here's the question though, why? Why is it important that we adjust our stick out? We need to make sure that we are focusing our arc to where it needs to go. If it doesn't, let's talk about like a T-joint. If we don't give ourselves enough stick out, what's going to happen is we're just going to heat this outside area, and there's going to be a little pocket in here called bridging. Okay, so we don't want to have that pocket area. Okay, now, what is high frequency? High frequency allows us to start the arc, and then when we're using AC, it also allows us to continue the arc. All right, so we're talking about adding filler metal. Okay, so this is the angle that we should be using, a 15 to 20 degree with our filler material. Boy, I'm losing my mind today, guys. And ultimately, all of you guys have been working on this. When we melt the pool, when we start the puddle, it's going to look like a little droplet of water. Okay, and then after we get that pool, okay, we're going to go on the leading edge, which means the front edge, and we're going to touch it, ding, with the filler metal. Now here's the thing. We want to make sure that our filler metal, it stays in that gas. But the thing is that if we leave it too closely in that next to our torch, it's actually going to make a little ball at the end, and it's going to drop off into our weld. We don't want that. Okay, we want to make sure that we keep it from being oxidized inside the shielding gas, but we don't want it so close that it's going to melt our rod before our weld pool is ready. Okay, so in order to do a lap joint, there doesn't have to have a filler metal. Okay, now here's the thing. I want you guys to think about lap joint. I know some of you guys have experienced lap joint, especially when we're doing oxy, and we have to think about how much heat disbursement do we have. Okay, now I want you to think about it. We have this edge here or this edge here. Which one is going to disperse the heat better? Well, we know this bigger edge is going to disperse the heat better, so ultimately it's best if we start there. Okay, so I always tell you guys, make sure you have good tack here, but if I start a little bit on the bottom and kind of work myself up, I'm able to do that without chewing away this top edge because I'm not heating it so much, okay, and eating it away, okay? And we're going to do the same thing. We're going to, but here's the thing, when we add filler, it's actually going to make like a little notch, and that's where we're going to add our filler metal, okay? But really, lap joints aren't used over 1/4 inch. We're going to use something else, and usually a lap joint is on 1/8 inch or less that we're going to do no filler. All right, horizontal. Challenge yourself, guys. We want to do horizontal. Okay, same kind of thing if we're going to do a butt joint, except this time, when we add our filler material, we're going to put it at the top. Now, why would I want to put it at the top of where I'm welding? I want to put it at the top because it's going to sag down, okay? And we don't want to put it in on the side, otherwise it's going to go past where we're heating, okay? We also don't want to have undercut, Okay, because remember, undercut is caused because we have a lot of heat. We're cutting into our base metal and we're not filling it up. Okay. All right, uphill, same kind of thing. Here's the thing though, when we work in TIG, often we don't work out of position because TIG is normally done in the shop. And usually you can move your part around. But it's really good to practice. It's important that we know how to do all sorts of positions because you never know when you're going to get into something where you have to do vertical up. And we're going to do the same thing, except now 90 in with a 10, with a 5 up, okay, with our torch. And then our filler is going to come in at a 10 to 15, okay, above it. Because, of course, gravity, right? So we're going to make sure that gravity doesn't get too big. All right, and overhead. It's going to work in that same way like we did flat, except this time it's we're turning our torch up. All right, pulsed. Let me talk about pulse. Pulse is something that is remarkable. We're going to use TIG pulsed when we have really thin materials that can get really distorted from a continuous seam. So ultimately, when we do a pulse, it's almost kind of like making a spot and then another spot and then another spot and then another spot and then another spot. Okay, so let me explain how it works. Okay, so we have 4 different things. It's called peak current, background current, pulses per second, and percentage of on time. It kind of talks about itself, but let me explain what I'm talking about. So when we talk about peak current means the most amount of current that I want. Okay, background current. After I hit the peak current, what kind of current is it going to go to? And let me explain this a little bit more. Pulses per second. How many times is this going to come on? And then percentage of on time. How long is it going to be to come on? So let's say that my peak current is 150 amps. And let's say my background current is 50. Okay, so it's going to turn on, zit, and let's say we want it for 2 seconds, zit, zit. After it's done, okay, it's going to drop down to my 50 amps, and this is where I move my torch. Okay, then it's going to turn back on, and I'm going to go on for 2 seconds, zit, zit, and then it's going to go off and down to my background current. Okay, and it's going to continue to go. So ultimately, it's creating a spot weld. So at my peak current is where I'm going to add my filler, and at my background current, this is where I'm going to move. Okay, so points to remember, TIG can be used for joining many different types of metals in different thicknesses in different types of joints. When we weld light gauge metal, backing bars can be used to prevent excessive melt through. My favorite is copper as well as aluminum, or we can even use steel when we're working with copper. When we use a water-cooled torch, guys, make sure the water is on. Make sure we got some, okay? It's a good habit to have. When we use TIG in the overhead position, we want to make sure that we lower the heat 5 to 10%. You know, I don't like it raining on me, and that's ultimately what happens. All right, so what does TIG stand for? Gas tungsten arc welding. So what are the advantages of TIG over other processes? The advantage is I can run thinner metals, different joint configurations, and different thicknesses, as well as different types, ferrous and not ferrous. So how do we start the arc and stop the arc? Well, it depends. We can start the arc in many different ways. The first one is high frequency, which means we do not have to touch the work. If we're going to do lift arc, we touch our tungsten to our work and pull up, and the current is started that way. When we do scratch start, the tungsten is scratched across the material like a match. Okay? And when we stop, it depends. If we're doing scratch, we kind of pull it away. If we're doing high frequency, we lower the amperage on the pedal. So what would be the proper torch angle for welding a butt joint? Well, depends on what type of butt joint. So I'm going to say if we have a flat joint, it is 90 degrees. Now, what is hot wire welding? I'm going to put a hot wire welding video up for you guys to understand. So what it is, it's pretty much TIG that actually has a semi-automatic feeder. Coolest stuff ever. If you get to do it, it's fun. All right, so how are welds produced? By the pulsed TIG process. Ultimately, the weld is produced on the peak current, and it makes kind of sort of a bunch of spot welds. So what kinds of metals can be welded with TIG? Ferrous and non-ferrous. So here it is. Why is joint cleanliness important? TIG does not have anything that will clean away any of the dirt, grime, rust, or oil that's in our materials. Okay, that means when we weld, we need to make sure that we're wire brushing and acetoning. If I don't have acetone, I'm going to get some soap and water, clean it really well, and make sure it's really dry. But we have to remember there's nothing there for to take, anything out. When we're talking about DCEN and DCEP, well, we use those when we have AC, so it helps cleaning and penetration. But when we don't have that, all we get is penetration, no cleaning. Okay? All right, guys, as usual, take care.